Hello again, fourth graders, and welcome back to Math Workshop. I'm really excited because today is the first day of a brand new unit in math. Today we are beginning Unit 4, and Unit 4 talks all about different strategies that we can use for multiplication. So I'm really excited to begin today's unit with you. Our first lesson that we're going to talk about is kind of a simple one, but it's a good review to kind of check in with what we know about how multiplication works and how we can use what we know about multiplication to multiply even bigger digits than we may have thought we could. So when we look at this word extended, it just means getting bigger, right? When we extend something, it means that we add more to make something bigger. So when we're talking about extended multiplication facts, what that really means is that we're using what we already know about fact triangles. And remember, fact triangles are those tools that we use to help us visualize factors in a multiplication problem and the product at sort of the top of the triangle. And then adding zeros for multiples of 10, multiples of 100, multiples of 1,000. So every time we are looking at a basic multiplication fact, we can use what we know about that basic starter fact. And even if those factors get bigger by multiples of 10, we know how to solve it because we know the basic fact to begin with. So for example, if I look at a fact triangle like this one, you know exactly what this looks like. It's a basic fact triangle that we've looked at since first grade, back when they were fact triangles for addition and subtraction. So here's a fact triangle for multiplication, and we know that it's multiplication because we see the symbols for multiplication. So remember that rather than just the standard old X for multiplication, you might also see an asterisk, and that just means that we're going to multiply. And this slash is also another way to label division. It looks a little bit like the way we organize fractions, doesn't it? We put a numerator and then a slash and then a denominator, but we know that fractions are really just a way of showing division. So when you see either one of these marks, these operation symbols, you know that they represent multiplication and division. So we know that we can use these numbers, these factors together, and we can multiply them together to equal the product. The two numbers that are the small numbers at the base of the triangle, these are the numbers that we can multiply together to equal the product or the answer in a multiplication problem. Or we can use what we know about division, start with the big number, 6, divide 6 into 3 equal groups, and we'll find out that there are 2 in each group. Or the other way around, if we start with 6 and we divide 6 into 2 groups, 3 will be in each group. So we use what we know about multiplication and division to work our way through this fact triangle. So when we're talking about how to extend this knowledge into a bigger multiplication problem with bigger factors, factors of 10, what we're going to do is we're going to concentrate first on what is the original fact. So in this particular problem, the original fact started out as 2 times 3 equals 6. That's the original basic fact. We know that we can now extend our knowledge of this problem, and we can write it in an even more advanced way with factors or multiples, of 10 by simply adding zeros. Here's what I mean. If I take this number 2 and I turn it into 20 by creating a multiple of 10, I'm just going to add that 0. So now instead of 2, I'm multiplying 20. If I still multiply by 3, I'm going to use what I know about the answer. 2 times 3 is still going to be 6. But because I added 1 0 to one of my factors, my product also needs 1 0. So now I can see that that 1 0 is going to transfer itself also to my product. I can even switch that around if I wanted to, and I could call it 2 times 30, and it would still equal 60, because as long as I'm adding 1 0 to one of the digits in my multiplication problem, to one of the factors. However many zeros I add to the factors, that's how many zeros I add to the product, because I'm multiplying by multiples of 10. Here's another example. I could keep growing this digit. Instead of 2, I could turn it into another multiple of 10. I could turn it into 200 and still multiply it by 3. So I'm still going to use what I know about the basic fact. 2 times 3 is still 6. But in this case, I, of course, have added 2 zeros to one of the factors. 2 zeros here. So because there are 2 zeros added to one of the factors, the product is also going to get bigger by 2 zeros. We could also change not just one of the factors, but we could change both factors. So for example, if I wanted 2 to become 20, and I wanted 3 to become 30, I still use what I know about the original fact. I know that 2 times 3 still equals 6. And in this problem, because I added a 0 to one of the factors, my product also needs 1 0. And because I added a 0 to this factor, I also need another 0. So each time I get bigger by a multiple of 10, my product also has to get bigger by a multiple of 10. So it's important that we think back to what do we already know, keep the problem as simple as possible, and then get bigger from there. Let's try another example together before you try this on your own. Keep in mind you're going to use what you already know about the original fact. Here's another one. 4 times 7 equals 28, or 28 divided by 7 equals 4. Either way, we know that the basic original fact in this problem is 4 times 7 equals 28. So even if your product is already 2 digits big, even if it's already got a tens place and a ones place, it doesn't matter, because in this instance, we're going to extend our multiplication facts by multiples of 10. So one way that we could write an extended fact is, of course, by turning 4 into 40 and leaving 7 alone. Because we have added 1 0, because we've gotten bigger by a multiple of 10, the answer still stays 28, because 4 times 7 is still 28. But because I got bigger by a multiple of 10 in one of the factors of my problem, the product also needs to get bigger by a multiple of 10. If I continue to do this, I could even extend 4 to 400 this time. I could do it even bigger. Keep 7 the same if you want to. Just keep track of how many zeros you added to one of the factors. In this case, 4 times 7 is still 28. That doesn't change. But because I added 2 zeros, because I got bigger by a multiple of 10, my product also needs to get bigger by that same multiple of 10. And I can do this no matter how many times I want to change the number. It doesn't matter how many ways I change the number. If I keep track of my zeros, we're all set. So if I wanted to create an extended fact like 400 times 700, I still could even do that. 4 times 7 is still 28, and that never changes. But in this case, I have to keep track of how many multiples of 10, how many zeros did I add to the problem. I added 2 to this factor, so I need to put those 2 in my product. And I added 2 to this factor, and they need to show up in my product as well. So then I remember that I can add my commas in by just counting 3 place value spots in. So friends, it doesn't matter how many zeros you add to these problems. We could call this problem 4 million times 7 million. And it doesn't matter how many zeros we add. It just says that the basic fact answer is still going to be 28. And then we count how many zeros we added to the original fact, how many zeros we added to this original factor, and all of the zeros we added need to be represented in the product. So today you're going to go forward and practice. This is actually really good review, not only of your basic fact knowledge. Remember, we really want to be automatic at this point in 4th grade. We want to be able to look at a multiplication problem and instantly know the answer. So this is good practice not only for extending your multiplication facts and learning how to get bigger by multiples of 10, but it's also a good way to practice your multiplication facts so that you can become automatic with them. So today you're going to go forward and try some of these problems on your journal pages. Be sure that you check out the Google Classroom because you're not doing every problem on every page, and I don't want you doing more work than you need to. So be sure that you're checking out the Google Classroom page for today's assignment. As always, if you want to do a few examples with me, you can hit me up in the chat and I'll be happy to meet with you. Try the journal pages first and see how you do. If you feel really successful and you feel that you know this material really well, go forward and try the exit ticket. If you notice on your journal pages that you're struggling and you might want to do a few examples with Ms. J, let me know before you do the exit ticket. We'll try some together, and then your exit ticket you can do independently when you feel a little bit more confident. So have fun practicing your extended facts. Welcome to Unit 4. I'm excited to see how this unit goes. Off you go, 4th graders.